Hello there, and welcome to this quiet corner of the cosmos where wonder meets the gentle rhythm of night. Tonight, we're not staying earthbound. We're drifting upward, past the familiar pull of gravity, past the comfort of atmosphere, to visit something that has watched over humanity since our very first breath, something so close we take it for granted, yet so strange that every new discovery reminds us how little we truly understand about our most faithful companion. The moon. Just saying the word conjures images we think we know. A silver disk hanging in darkness, a romantic backdrop for poets and lovers, a stepping stone for astronauts. But what if I told you that everything you think you know about the moon is just the surface of a mystery so profound it challenges our understanding of how worlds are born, how they die, and how they shape the very essence of life itself? Tonight, as you settle into the rhythm of this exploration, we're going to discover that the moon isn't just stranger than you think. It's stranger than you could ever imagine. And in that strangeness lies a story that reaches back billions of years, touches every tide that has ever kissed a shoreline, and extends forward into futures we're only beginning to glimpse. Before we begin this journey through lunar mysteries, I'd love to know where you are right now. Are you watching the moon through your window? Can you see its face, perhaps half hidden by clouds, casting shadows across your room? Or maybe it's daylight where you are, and the moon is invisible, playing its eternal game of hide and seek with the sun. Either way, you're about to discover that this celestial companion is far more active, far more dynamic, and far more essential to your existence than any textbook ever told you. If this kind of gentle cosmic exploration speaks to you, if you find peace in questions that stretch across deep time and vast distances, consider staying with us for this entire journey. There's something deeply satisfying about letting your mind wander through the universe while your body finds rest. And there are more mysteries waiting in the videos that follow, each one a doorway into the profound and the beautiful. So let's begin with something that sounds impossible. Picture this. You're standing on the moon's surface, and despite the fact that the sun is blazing overhead in a pitch-black sky, you cannot see your own feet. The moment you step into shadow, everything disappears into absolute darkness. Your hands, your tools, the ground beneath you, all swallowed by a blackness so complete, it's almost alive. This isn't science fiction. This was the reality that Apollo astronauts faced, and it nearly made their missions impossible. But why? What makes lunar shadows so different from the gentle shadows we know on Earth? The answer takes us into the first of many revelations about just how alien our familiar moon really is. On Earth, we live in a world of soft transitions. Even in the deepest shadow, there's always some light bouncing around, scattered by our atmosphere, reflected off particles in the air. We can see into shadows because light finds a way to bend around corners, to fill dark spaces with a gentle glow. It's so natural to us that we never really think about it, but the moon exists in a universe of absolutes, with no atmosphere to scatter light, no particles to soften the harsh contrast between day and night. Lunar shadows are not mere absence of light. They are voids, perfect, impenetrable darkness that begins exactly where the sunlight ends, with a boundary so sharp you could cut yourself on it. Imagine trying to work on a delicate repair when your own shadow makes your hands disappear. Imagine the psychological effect of stepping from brilliant, blazing sunlight into absolute nothingness. Some astronauts described it as stepping into a cave, others as falling into a pit. The human mind, evolved under Earth's gentle skies, struggled to process this alien landscape of extremes. But the shadows held an even stranger secret. As astronauts moved across the lunar surface, they began to notice something that shouldn't exist in a world without air, without moisture, without any medium to bend or scatter light. Their own shadows were surrounded by halos, bright, ghostly aureoles that seemed to dance around the dark silhouettes of their bodies. This phenomenon, known as the opposition effect, occurs when light reflects back from a surface at exactly the angle it arrived. On Earth we rarely see it because our atmosphere diffuses everything. But on the Moon, with its fine glassy dust created by billions of years of meteorite impacts, the effect creates an otherworldly display that made astronauts question what they were seeing. Think about that for a moment. We sent human beings to what we thought was a familiar, well-understood world. We'd observed the Moon for thousands of years, mapped its surface, calculated its orbit, predicted its phases, and yet, within moments of setting foot on its surface, our explorers encountered phenomena so strange they seemed supernatural. This is the first hint of something profound. The Moon is not just a large rock orbiting Earth, it's a world operating under rules so different from our own that even basic experiences like shadows and light become alien encounters. And if something as simple as shadow can surprise us, what other secrets might be hidden in the familiar face we see every night? To understand why the Moon is so strange, we need to travel back in time. Not years or centuries, but billions of years, to an epoch so violent and chaotic that it makes every disaster movie seem quaint by comparison. We need to witness the birth of the Moon itself, an event so catastrophic that its echoes still shape every tide, every day, every season we experience. Picture the early Earth, just 4.5 billion years ago. It's not the blue marble of today, but a hellish world of molten rock and poisonous skies. The solar system is young, wild, filled with wandering planets and massive chunks of debris still finding their places in the cosmic dance. And somewhere in this chaos, a Mars-sized world called Theia is on a collision course with our planet. The impact, when it comes, is beyond imagination. Theia strikes Earth at an angle, not head-on, but with a glancing blow that tears apart both worlds. The energy released makes every volcanic eruption, every earthquake, every hurricane that has ever occurred on Earth seem like gentle whispers. Rock vaporizes, the surface of both planets melts and flows like water. Massive chunks of molten material spray into space, carrying with them the raw ingredients of our future Moon. But here's where the story becomes even more remarkable. This wasn't just destruction, this was creation on a cosmic scale. The debris from both worlds, superheated and spinning, began to coalesce in orbit around what remained of Earth. Over thousands of years, gravity pulled this material together, forming a new world that had never existed before. A world that was part Earth, part Theia, but something entirely unique. This origin story explains so much about the Moon's strangeness. It explains why the Moon is so large relative to Earth, unlike any other planet-moon system in our solar system. It explains why lunar rocks brought back by Apollo missions share so many characteristics with Earth rocks, yet are subtly different. It explains why the Moon's core is proportionally smaller than Earth's, and why its composition tells a story of violent formation rather than gentle accretion. But this cosmic collision did more than create the Moon. It fundamentally shaped the world we live on. The impact tilted Earth's axis, giving us our seasons. The gravitational dance that followed gave us our 24-hour day, our tides, our stable climate. Without that ancient catastrophe, Earth might spin wildly through space, its poles wandering, its climate swinging between extremes that would make complex life impossible. So every time you watch the Moon rise, you're seeing the remnant of the most important collision in Earth's history. You're looking at a world born from violence, shaped by forces that dwarf human comprehension, yet now serving as the gentle guardian that makes our existence possible. And yet, for all we know about this ancient impact, mysteries remain. Computer simulations can recreate the collision, but they struggle to explain every detail of the Moon we see today. Why is the Moon's orbit tilted the way it is? Why doesn't it have more water if it formed partially from Earth's material? How did it end up with such a perfect size and distance to create the total solar eclipses that have amazed humans for millennia? These questions remind us that even our best theories about the moon's origin are still incomplete. The story of Theia and the Great Collision explains much, but it also reveals how much we still don't understand about the forces that shaped our cosmic neighborhood. In the quiet museums where lunar samples rest behind glass, there's a secret that changed everything we thought we knew about the moon. When Apollo astronauts returned with their precious cargo of moon rocks, scientists expected to find ancient, unchanged materials from a dead world. Instead, they discovered something that should have been impossible. The rocks were magnetic. Not just slightly magnetic, but powerfully so. These weren't the weak magnetic signatures you might find in any random rock. These were materials that had been shaped by a magnetic field as strong as Earth's is today, which meant that sometime in its past, the moon had possessed something it shouldn't have been able to create: a global magnetic field generated by a churning, molten core. This discovery sent shockwaves through the scientific community. The moon, small and cold, should never have been able to maintain the kind of internal dynamo that creates planetary magnetic fields. Yet here was undeniable evidence that it once had exactly that. The lunar rocks told a story of a world that was once magnetically alive, protected by an invisible shield that deflected the harsh radiation of space. But what made this discovery even more mysterious was what came next: the realization that this magnetic field had vanished completely. The moon that protected early Earth from cosmic debris and helped stabilize our planet's rotation had once been shielded by its own magnetic bubble. Now that protection was gone, leaving the moon naked to the violence of space. The loss of the moon's magnetic field wasn't just a minor change in cosmic architecture. It was a transformation that would have had profound effects on both the moon and Earth. Without magnetic protection, the moon's thin atmosphere was gradually stripped away by solar wind. Any water on its surface would have been broken down and lost to space. The moon became the airless, waterless world we see today, but it hadn't always been that way. Recent studies of ancient lunar rocks suggest that the moon's magnetic field didn't just fade gradually, it seems to have shut down suddenly, catastrophically, sometime between 3.5 and 4 billion years ago. What could cause such a dramatic change? Some scientists theorized that the moon's core simply cooled below the threshold needed to maintain convection currents. Others suggest that massive impacts might have disrupted the delicate balance of the lunar dynamo. But there's another possibility, one that's even more intriguing. What if the moon's magnetic field didn't just disappear? What if it was somehow transferred, absorbed, or integrated into Earth's own magnetic system? The timing of the moon's magnetic field loss coincides roughly with changes in Earth's own magnetic behavior, suggesting a connection we're only beginning to understand. This magnetic mystery has profound implications for our understanding of planetary evolution. If small worlds like the moon can generate powerful magnetic fields and then lose them, what does that tell us about the magnetic histories of other planets? Mars, we now know, once had a magnetic field that vanished, leaving it vulnerable to atmospheric loss. Venus might have had one, too. Are planetary magnetic fields more fragile than we thought? The loss of the moon's magnetic field also raises questions about the role of magnetism in the development of life. Earth's magnetic field protects us from deadly cosmic radiation, making complex life possible. If the moon once had similar protection, could it have harbored life during its magnetic era? Could there be fossilized remains of lunar life forms waiting to be discovered beneath the surface of our seemingly sterile satellite? These aren't just academic questions. As we plan for humanity's return to the moon, understanding its magnetic history becomes crucial. The same solar radiation that stripped away the moon's atmosphere will pose a constant threat to future lunar colonists. The moon's magnetic past reminds us that even the most fundamental characteristics of worlds can change, vanish, and leave behind only subtle clues for future investigators to puzzle over. And so the moon keeps its secrets, even as we think we understand it. In museum cases around the world, those magnetic moon rocks continue to whisper stories of a world that once was, a protective companion that lost its shield and became the mysterious alien place that continues to watch over us from its silent orbit. This is just the beginning of our exploration into the moon's hidden nature. As we continue this journey together, we'll discover that magnetism is only one of many characteristics that make our satellite far stranger than it appears. We'll explore the vast metallic masses hidden beneath its surface, the ice deposits that change everything we thought we knew about lunar resources, and the recent discoveries that have forced scientists to completely reconsider what kind of world the moon really is. But for now, let the image settle in your mind. A younger moon, protected by invisible fields of magnetic force, perhaps even hosting an atmosphere, maybe even puddles of liquid water reflecting the blue earth hanging in its sky. A world that was, in its own way, alive. A world that changed, that lost its protection, that became the airless guardian we know today. The story of that transformation and what it means for understanding worlds throughout the universe continues in our next exploration together. There's something extraordinary happening right now as you listen to these words. The ground beneath your feet, solid and unmoving as it seems, is actually dancing, rising and falling in a slow, gentle rhythm that your body can't feel, but sensitive instruments can measure. The earth itself breathes twice each day, lifting and settling by as much as 16 inches, pulled by the same invisible force that moves our oceans. This is the moon's hidden power, working not just on water, but on rock itself. On the very bones of our planet, we call them solid earth tides, and they reveal something profound about the relationship between our world and its companion. The moon doesn't just light our nights and pull our seas. It flexes the entire earth like a stress ball in the hands of a giant, kneading and working the rock beneath our feet in ways that fundamentally shape our planet's character. But this constant flexing does more than just move stone. Deep within the earth, in places where water has found its way into cracks and crevices, this rhythmic pressure creates something unexpected: underground tides, vast bodies of water, hidden from sunlight, rising and falling in sync with the moon's passage overhead. These subterranean seas exist in caverns we've never seen, flowing through networks of stone we've never mapped, responding to gravitational forces that connect them directly to our satellite. Recent discoveries have revealed that some of these underground water systems are enormous. Beneath the surface of continents, flowing silently through limestone caverns and fractured bedrock, there are rivers and lakes that dwarf many of the surface water bodies we know. And all of them, every hidden stream and secret pool, pulse with the moon's rhythm. This hidden hydrosphere tells us something remarkable about the nature of worlds. Water finds a way. It seeps, it flows, it persists in places we never thought to look. And where there's water, especially water that moves and changes, there's the possibility of chemistry, of complexity, of processes we're only beginning to understand. The implications are staggering when you consider them fully. If the moon can create hidden oceans within the solid earth, what other invisible influences might it have? What other systems might be dancing to gravitational rhythms we've never recognized? The more we look, the more we discover that the moon's influence extends far beyond the obvious effects we learned about in school. Think about the implications for life itself. If underground water systems are responding to lunar cycles, then the chemistry of groundwater, the movement of nutrients through soil, even the behavior of underground ecosystems might all be subtly synchronized with the moon's orbit. We're discovering that the moon doesn't just affect what we can see, it reaches into the hidden spaces of our world and orchestrates processes we never suspected. And this is just on Earth. What about other worlds with their own moons? What hidden tides might be flowing beneath the surfaces of distant planets, creating environments for life in places we've never thought to look? Sometimes the most profound discoveries come from the deepest wounds. In 1994, when the comet Shoemaker-Levy 9 crashed into Jupiter, we watched in amazement as fragments the size of mountains created explosions visible across the solar system. But those impacts, spectacular as they were, pale in comparison to the ancient catastrophe whose scars still mark the far side of the Moon. The South Pole Aitken Basin is a wound that defies comprehension. Imagine a crater so vast that it could swallow most of the United States, so deep that if you stood at its center, the rim would be beyond your horizon in every direction. This isn't just the largest impact crater on the Moon, it's one of the largest known impact craters in the entire solar system. A scar left by a collision so violent it nearly shattered our satellite completely. But size alone doesn't capture the true strangeness of this ancient impact site. Deep beneath the crater floor, gravitational measurements have revealed something that shouldn't exist. A mass of metal so enormous that it's actually warping space-time around it. This buried anomaly weighs as much as 2.4 quadrillion tons, pulling the crater floor downward by more than half a mile through the sheer force of its gravitational field. What could create such a massive concentration of metal? The leading theory suggests that when the asteroid struck the Moon 4 billion years ago, it was so large and moving so fast that its metallic core actually punched through the Moon's crust and became embedded in the mantle below. The impactor's iron and nickel heart, compressed and heated by the collision, sank into the Moon's interior, where it remains today. A metallic monument to violence on a scale we can barely imagine. But this explanation raises as many questions as it answers. How did such a massive chunk of metal maintain its integrity during such a catastrophic impact? Why didn't it melt completely and mix with the Moon's own materials? And perhaps most mysteriously, how has it remained stable for billions of years, creating a gravitational anomaly so strong that every spacecraft that passes over it must adjust its trajectory? The presence of this buried mass tells us something profound about the Moon's interior structure. For the metal to remain concentrated rather than spreading out, the Moon's mantle must be far more rigid and solid than we previously thought. This suggests that the Moon's interior cooled and solidified much more quickly than Earth's, creating a world that preserves ancient impacts like a cosmic museum. Recent computer simulations of the South Pole Aitken impact have revealed even more startling possibilities. The collision that created this crater was so powerful that it might have blasted material completely off the Moon's surface and into space. Some of that debris could have traveled to Earth, seeding our planet with lunar material billions of years before humans ever dreamed of space travel. We might literally be walking on pieces of the Moon that fell to Earth as the result of this ancient catastrophe. But there's another, even more intriguing possibility. What if the object that created the South Pole Aitken Basin wasn't just a random asteroid? What if it was something far more interesting? A fragment from the same collision that created the Moon in the first place? Computer models suggest that the impact that formed the Moon would have created debris of many different sizes, not all of which would have immediately coalesced into our satellite. If this theory is correct, then the South Pole Aitken Basin represents a kind of cosmic archaeology, a record of the Moon's violent birth preserved in stone and metal. The massive buried anomaly might be a piece of Theia itself, the mysterious world that collided with early Earth. Deep beneath the lunar surface, we might be looking at the preserved heart of a planet that died 4.5 billion years ago. This transforms our understanding of what the Moon represents. It's not just Earth's companion, formed from our planet's material. It might also be a tomb, a repository containing the remains of worlds that no longer exist. Every time we look at the Moon, we might be seeing a memorial to cosmic violence, a reminder that the solar system's current stability was built on a foundation of catastrophic collisions. The South Pole Aitken Basin also raises questions about the Moon's role as Earth's protector. If impacts this large were common in the early solar system, how many potential Earth killers did the Moon absorb? How many times did our satellite take a hit that might otherwise have sterilized our planet? The scarred face of the moon might represent not just its own violent history, but the violence it prevented from reaching us. These ancient wounds tell stories that stretch across billions of years, connecting the formation of worlds to the possibility of life, linking cosmic catastrophes to the gentle processes that shaped our existence. And they remind us that even in the most familiar objects, the most studied and mapped and photographed worlds, profound mysteries still wait to be discovered. To understand just how alien the moon really is, imagine stepping outside on the hottest day you've ever experienced. Now imagine that same heat, but without air to carry it away, without moisture to evaporate and cool your skin, without any buffer between you and the raw fury of stellar radiation. On the moon's equator during lunar day, temperatures soar to 250 degrees Fahrenheit, hot enough to boil water, hot enough to kill any unprotected human being in minutes. But that's only half the story. Wait 14 Earth days, and that same spot becomes a frozen hell where temperatures plummet to 208 degrees below zero. These aren't gradual seasonal changes like we experience on Earth. This is a world of absolutes where the difference between day and night is a temperature swing of nearly 500 degrees, creating thermal stresses that constantly crack and reshape the lunar landscape. This extreme temperature variation exists because the moon lacks the moderating influence of atmosphere and water that keeps Earth's temperatures relatively stable. Without air to distribute heat around the globe, without oceans to absorb and release thermal energy, each point on the moon's surface experiences the full, unfiltered power of solar radiation during its 2-week day, followed by the absolute cold of space during its 2-week night. The effects of these temperature extremes are written across the moon's surface in ways that tell stories of thermal violence. Rocks expand and contract with such force that they split apart along crystalline boundaries, creating the fine, glassy dust that covers the lunar landscape. This isn't erosion as we know it on Earth, caused by wind and water. This is thermal fracturing, the slow disintegration of solid rock under the stress of constant heating and cooling. But recent discoveries have revealed that the moon's temperature story is even more complex than we thought. In the permanently shadowed regions near the lunar poles where sunlight has never penetrated, temperatures remain constant at around 400 degrees below zero. These areas are colder than the surface of Pluto, colder than the space between stars, creating natural laboratories where materials have remained unchanged for billions of years. And in these frigid polar regions, we've made one of the most important discoveries in lunar science: water ice. Not just traces of water molecules scattered through the regolith, but actual deposits of frozen water preserved in the ultimate deep freeze of permanent shadow. Some of these ice deposits may be billions of years old, older than complex life on Earth, containing within their crystalline structure a record of the solar system's chemical history. The presence of water ice in lunar cold traps transforms our understanding of what the moon might have been in the past. If water exists there now, in the harshest possible conditions, what might have existed when the moon was warmer, when it still had its magnetic field and perhaps even a thin atmosphere? Could there have been periods in lunar history when liquid water existed on the surface, creating temporary seas that reflected the blue Earth in their depths? Recent modelling suggests that during certain periods in the moon's past, when its axial tilt was different and its orbit was closer to Earth, some regions might have experienced temperatures that allowed liquid water to exist temporarily. These wouldn't have been permanent oceans, but rather seasonal lakes and streams that formed during brief warm periods and then froze again as conditions changed. The thermal history of the moon also provides crucial insights into planetary formation throughout the universe. The extreme temperature variations we see on our satellite are typical of what we'd expect on airless worlds orbiting close to their stars. This makes the moon a laboratory for understanding exoplanets, those distant worlds we're discovering around other stars. By studying how temperature extremes shape the moon's geology and chemistry, we're learning to interpret the signals we receive from worlds we'll never visit. But perhaps most remarkably, these temperature extremes have created their own strange form of lunar weather. Without atmosphere to create storms or precipitation, the moon experiences thermal weather, patterns of heating and cooling that create their own form of circulation. Hot spots expand and radiate energy. Cold spots contract and absorb it, creating subtle flows of thermal energy across the landscape that influence everything from the behavior of lunar dust to the formation of surface features. This thermal circulation might even play a role in the transport of water molecules across the lunar surface. During the intense heat of lunar day, water molecules might be liberated from minerals and migrate toward the cold traps at the poles, creating a kind of water cycle without liquid water, a circulation system driven entirely by temperature extremes. As we prepare for humanity's return to the moon, understanding these temperature extremes becomes crucial for survival. Future lunar habitats will need to withstand temperature swings that would destroy most earthbound structures. They'll need heating systems powerful enough to survive the cold of space and cooling systems capable of dealing with temperatures that would melt lead. But these challenges also represent opportunities. The temperature extremes that make the moon so hostile to life also make it an ideal location for certain types of scientific research and industrial processes. The ultra-cold regions could serve as natural laboratories for studying materials at temperatures impossible to achieve on Earth, while the high-temperature zones could be used for manufacturing processes that require extreme heat. The moon's temperature story reminds us that even the most fundamental aspects of worlds can be radically different from our earthbound experience. What we consider normal, the gentle warming of sunrise and cooling of sunset, the moderate temperatures that allow liquid water to exist. These are rare gifts in a universe dominated by extremes. Deep beneath the moon's ancient surface, something is stirring. Not life as we know it, but movement nonetheless. A slow, rhythmic flexing that creates tremors unlike anything experienced on Earth. These are moonquakes, and they reveal that our supposedly dead satellite is far more geologically active than we ever imagined. When Apollo seismometers first detected these lunar tremors, scientists were puzzled by their characteristics. Unlike earthquakes, which typically last only a few minutes, moonquakes can continue for over half an hour, their seismic waves reverberating through the moon's interior like sound echoing in a cathedral. The moon rings like a bell when struck, its dry interior allowing vibrations to travel much farther than they would through Earth's water-rich rocks. But what causes these extended tremors? The answer connects us once again to the gravitational dance between Earth and Moon. As our planet's gravity pulls on the moon's interior, it creates stresses that build up over time until they're released in sudden movements along fault lines deep within the lunar structure. These tidal moonquakes occur on predictable cycles, strongest when the moon is closest to Earth in its elliptical orbit. Recent analysis of decades of seismic data has revealed something even more intriguing. The moon experiences different types of quakes at different depths. Deep moonquakes, occurring about 700 kilometers below the surface, are relatively gentle and appear to be caused by Earth's gravitational pull. But shallow moonquakes happening much closer to the surface can be surprisingly strong and seem to be related to the gradual cooling and contraction of the moon itself. Perhaps most mysteriously, some moonquakes appear to be triggered by thermal stresses. As the moon rotates through its extreme day-night temperature cycle, the constant expansion and contraction of surface materials creates fractures that can propagate deep into the interior. These thermal moonquakes suggest that the moon's structure is more fragile than we thought, constantly cracking and adjusting as it responds to temperature changes. The extended duration of moonquakes tells us something profound about the moon's internal structure. Unlike Earth, which has a wet interior that dampens seismic waves, the Moon appears to be relatively dry throughout its interior. This allows vibrations to travel much farther, creating the bell-like ringing effect that can last for hours after the initial tremor. But there's another type of lunar seismic activity that's even more intriguing: impact moonquakes. Every time a meteorite strikes the Moon's surface, it creates seismic waves that propagate through the interior. By studying these impact signatures, scientists have been able to map the Moon's internal structure in ways that would be impossible from surface observations alone. These impact studies have revealed that the Moon has a small, partially molten core surrounded by a solid mantle that extends most of the way to the surface, but the details of this structure tell a story of a world that cooled much more rapidly than Earth, losing its internal heat and becoming geologically inactive much earlier in its history. The seismic data also suggests something unexpected. The Moon's interior might not be completely uniform. There appear to be regions of different density and composition, possibly remnants of the violent impact that created the Moon in the first place. These variations could explain some of the gravitational anomalies that spacecraft experience when orbiting the Moon. Recent computer modeling, based on moonquake data, has suggested that the Moon might still have small pockets of liquid water deep within its interior. The constant flexing caused by Earth's gravity could generate enough heat through friction to keep some water liquid, even in the Moon's generally cold interior. If confirmed, these hidden lunar aquifers could represent some of the oldest liquid water in the solar system. The discovery of ongoing seismic activity also has important implications for future lunar exploration. Astronauts living on the Moon will need to deal with ground that occasionally shakes for extended periods. Lunar habitats will need to be designed to withstand not just the temperature extremes and radiation of the lunar surface, but also the structural stresses of regular moonquakes. But perhaps most remarkably, the pattern of moonquakes suggests that the Moon's interior is still evolving. The gradual cooling and contraction of the lunar core continues to this day, meaning that the Moon is still adjusting its internal structure billions of years after its formation. In a sense, the Moon is still being born, still settling into its final configuration. This ongoing geological activity connects the Moon's ancient past to its dynamic present, reminding us that even worlds we consider geologically dead can harbour hidden processes that continue to shape their character. The Moon's seismic pulse is a reminder that in the cosmos, stillness is often an illusion, and even the most familiar objects can surprise us with their hidden vitality. As we've journeyed together through these lunar mysteries, we've discovered that our Moon is far more than the simple, unchanging companion we once thought it to be. From its violent birth to its hidden magnetism, from its buried metallic anomalies to its ongoing seismic activity, the Moon continues to challenge our understanding of how worlds form, evolve, and influence each other across the vast distances of space. But our exploration has only scratched the surface of cosmic mysteries. The same forces that shape the Moon, the gravitational dances, the impact events, the thermal extremes, these processes are at work throughout the universe, creating worlds and systems of breathtaking complexity and beauty. In our next journey together, we'll explore an even more profound mystery, one that touches the very foundation of existence itself. We'll ask whether the precise conditions that allow life to flourish on Earth are the result of cosmic coincidence, or whether there might be deeper principles at work, hidden patterns that suggest our universe itself might be stranger and more purposeful than we ever dared imagine. Join me next time for Earth Was Designed to Be Perfect, Sleep documentary, where we'll discover that the fine-tuning of our world extends far beyond the Moon's influence into the very structure of reality itself. There's something almost musical about the way water moves beneath the Moon's surface, even now, billions of years after we thought it had all escaped to space. In the deepest polar craters, where sunlight has never touched the ground, recent discoveries have revealed not just ice but entire frozen rivers, ancient waterways that once flowed when the moon was young and the solar system was still finding its rhythm. These aren't small deposits. We're talking about billions of tons of water ice, more than enough to fill entire lakes, preserved in temperatures so cold they make Antarctica seem tropical. Some of this ice has been lying undisturbed for so long that it contains within its crystalline structure a chemical record of the early solar system, a frozen library of cosmic history waiting to be read. But here's what makes this discovery truly extraordinary. The water isn't uniformly distributed. It forms patterns, channels, concentrated deposits that suggest it once flowed in organized ways across the lunar surface. Computer models based on the moon's ancient axial tilt and orbital characteristics suggest there were periods lasting millions of years when parts of the moon experienced temperatures warm enough for liquid water to exist. Imagine that ancient moon tilted at a different angle, receiving sunlight in regions that are now permanently dark. Picture temporary streams flowing across the regolith, pooling in crater basins, creating brief oases where complex chemistry could unfold. These wouldn't have been permanent oceans, but seasonal water systems that appeared and disappeared as the moon's orientation shifted over geological time. The implications are staggering when you consider them fully. If liquid water existed on the moon for extended periods, even briefly by geological standards, then the moon might once have been capable of supporting the kinds of chemical processes that lead to complexity, to organization, perhaps even to primitive forms of life. Recent analysis of lunar meteorites, pieces of the moon that were blasted into space by impacts and eventually fell to Earth, has revealed something even more intriguing: organic compounds. Not life itself, but the carbon-based molecules that serve as life's building blocks. These compounds could have formed through purely geological processes, but their presence suggests that the ancient moon was a more chemically active place than we ever imagined. The discovery of extensive water ice has also revealed something unexpected about the moon's present-day activity. Even now, water molecules are migrating across the lunar surface, hopping from one cold trap to another in a process driven by the extreme temperature variations we explored earlier. During the blazing heat of lunar day, water molecules embedded in minerals are released and begin a slow journey across the airless landscape, eventually settling in the permanently shadowed regions where they can remain stable for billions of years. This ongoing water migration creates a kind of hydrological cycle without rivers or rain, a circulation system driven entirely by temperature and the vacuum of space. It's unlike anything we see on Earth, yet it follows its own elegant logic, connecting the moon's scorching equatorial regions to its frozen polar deposits through an invisible network of molecular transport. The presence of all this water changes everything about how we think of the moon's future. Instead of a resource-poor wasteland, we're looking at a world that could potentially support sustained human presence. Water can be split into hydrogen and oxygen for rocket fuel, consumed as drinking water, and used to create breathable atmospheres for lunar habitats. The moon isn't just a destination for brief visits. It could become humanity's first foothold in the deeper solar system. But the water tells us something even more profound about the nature of worlds themselves. We're discovering that water is far more common and persistent than we once thought. It exists in the most unlikely places, survives in the harshest conditions, and finds ways to circulate and concentrate, even in environments that seem completely hostile to its presence. This has profound implications for our search for life beyond Earth. If water can persist on the moon, in permanently shadowed craters and buried beneath the surface, then it might exist in similar refuges throughout the solar system. The same processes that preserve water on the moon might be at work on asteroids, on the moons of Jupiter and Saturn, even in the outer reaches of the solar system, where we never thought to look. Sometimes the most important discoveries come from looking at familiar things in new ways. For decades, we've known that the moon's surface is covered in bright streaks and swirls, mysterious markings that seem to have no connection to impact craters or volcanic activity. They appeared to be painted across the landscape by some unknown process, creating patterns that were beautiful but inexplicable. Recent missions have finally solved this ancient puzzle, and the answer reveals something remarkable about the moon's magnetic past. These bright swirls, it turns out, are areas where local magnetic fields have protected the lunar surface from the solar wind, preserving lighter-coloured material, while the surrounding regions have been darkened by billions of years of particle bombardment. But where do these local magnetic fields come from? The answer takes us back to the moon's lost global magnetosphere, the planet-wide magnetic field that vanished billions of years ago. When that global field collapsed, it didn't disappear uniformly. Instead, certain regions retained their magnetism, creating isolated pockets of magnetic protection scattered across the lunar surface. These magnetic anomalies appear to be concentrated in areas where large impacts occurred while the moon still had its global magnetic field. The tremendous heat and pressure of these collisions created iron-rich melts that became permanently magnetized, preserving the ancient magnetic field lines in solid rock. Now, billions of years later, these magnetized regions continue to deflect charged particles, creating the beautiful swirl patterns we see today. Think about what this means for our understanding of planetary magnetic fields. The moon has become a natural laboratory where we can study the fossilized remains of ancient magnetism. By mapping these magnetic anomalies and understanding how they are formed, we're learning about processes that operate throughout the solar system, on worlds both ancient and modern. Mars, we now know, once had a global magnetic field that vanished, leaving behind only scattered magnetic anomalies in its ancient rocks. Venus might have had one too before its thick atmosphere and extreme temperatures erased most traces of its magnetic past. The moon's preserved magnetic signatures give us a window into what these other worlds might once have been like when they were magnetically alive. But the lunar magnetic anomalies tell us something even more intriguing. Computer models suggest that these localized fields might be strong enough to create small pockets of protected atmosphere around certain regions of the moon. If charged particles from the solar wind can be deflected by these fields, then perhaps lighter gases released from the lunar interior could be trapped and concentrated in these magnetic bubbles. Recent observations have found traces of argon and other gases concentrated near some of the strongest magnetic anomalies, suggesting that these ancient magnetic fields might still be actively shaping the moon's tenuous atmosphere. In a sense, the moon's lost magnetosphere lives on in these scattered refugees, continuing to influence the lunar environment billions of years after the global field disappeared. This discovery has profound implications for future lunar exploration. These magnetically protected regions might offer natural shelters from radiation, areas where astronauts could work with reduced exposure to the harmful particles that constantly bombard the lunar surface. They might also be places where the moon's own gases have concentrated over time, creating potential resources for future missions. The magnetic swirls also serve as a reminder of how much the moon has changed over its long history. The bright patterns we see today are the visible traces of processes that occurred when the solar system was young, when the moon was hot and magnetically active. They're like cosmic fossils, preserving evidence of conditions that existed billions of years ago, and they raise tantalizing questions about what other traces of the ancient moon might be preserved in places we haven't yet learned to look. If magnetic fields can be fossilized in rock, what other aspects of the moon's past might be waiting to be discovered? Could there be preserved traces of the moon's ancient atmosphere, locked away in polar ice or buried beneath layers of impact debris? The story of the magnetic swirls reminds us that the moon is not just a record of impacts and volcanic activity. It's a library of planetary processes, a place where the history of magnetic fields atmospheres, and surface chemistry has been preserved in ways that allow us to read the story of how worlds evolve over cosmic time. Every second, as you listen to these words, the moon is pulling at your body with invisible threads of gravity. The effect is subtle, far too small for you to feel, but sensitive instruments can measure it. Your body actually stretches slightly toward the moon, elongating by microscopic amounts as our satellite passes overhead. You are, in the most literal sense, dancing with the moon, your very atoms responding to gravitational music that has been playing since the solar system began. This intimate connection extends far beyond the human body. The moon's gravitational pull affects everything on Earth, from the flow of underground rivers to the migration patterns of animals, from the timing of earthquake swarms to the behavior of Earth's magnetic field. We're only now beginning to understand the full scope of lunar influence on our planet's systems. Consider the phenomenon of earthquake clustering. For decades, seismologists noticed that major earthquakes seem to occur in patterns, with certain periods showing increased activity while others remained relatively quiet. Recent analysis has revealed that these patterns correlate with lunar cycles, particularly during times when the moon's gravitational pull is strongest, due to its elliptical orbit. The mechanism is subtle but profound. The moon's gravity doesn't cause earthquakes directly, but it can trigger them in fault systems that are already under stress. When tectonic plates are balanced on the edge of movement, the additional gravitational stress from the moon can provide the final push needed to release built-up energy. In essence, the moon acts as a cosmic timekeeper, helping to regulate when and where the Earth releases its internal tensions. This lunar influence extends into the biological realm in ways that continue to surprise researchers. Many species have evolved internal rhythms that synchronize with lunar cycles, not just marine organisms that need to coordinate with tides, but terrestrial animals whose connection to the moon is far more mysterious. Coral reefs across the world's oceans spawn in mass, synchronized events that occur during specific lunar phases, usually the full moon. This coordination ensures that reproduction happens when tidal conditions are optimal for dispersing eggs and larvae, but similar lunar synchronization has been observed in animals that have no direct connection to ocean tides. Certain bird migration patterns, the breeding cycles of some mammals, even the behavior of insects living far from any coastline. The mechanism behind this terrestrial lunar influence remains largely mysterious. Some researchers suggest that animals might be sensitive to the subtle changes in Earth's magnetic field that occur as the moon orbits our planet. Others propose that the slight variations in gravitational force, while too small for us to feel, might affect biological processes at the cellular level. Recent studies have even found correlations between lunar cycles and human behavior, though these connections remain controversial. Emergency room visits for certain types of injuries show statistical increases during full moons. Sleep patterns in some individuals appear to shift in response to lunar phases, even when people are isolated from moonlight and have no conscious awareness of the lunar cycle. These findings suggest that the relationship between Earth and Moon extends far deeper into the fabric of life than we previously understood. We're not just observers of the Moon's gravitational influence, we're participants in it, our bodies and behaviours subtly synchronized with celestial rhythms that connect us to the broader cosmos. The Moon also influences Earth's magnetic field in ways that cascade through multiple systems. As our satellite orbits through Earth's magnetosphere, it creates subtle disturbances that propagate through the magnetic field lines. These disturbances can affect the behavior of charged particles in the upper atmosphere, influencing everything from aurora displays to radio communications. During certain lunar phases and orbital positions, these magnetic interactions can trigger cascades of electromagnetic activity that ripple through Earth's entire electrical system. Power grids occasionally experience unexplained fluctuations that correlate with lunar position. Sensitive electronic equipment sometimes malfunctions during periods of strong lunar magnetic influence. These connections remind us that the Earth-Moon system is not just two separate bodies orbiting through space. It's an integrated system, a cosmic partnership where changes in one partner inevitably affect the other. The Moon shapes Earth's magnetic environment. Earth's gravity affects the Moon's internal structure, and both bodies continue to evolve together in ways that influence everything from the deepest ocean trenches to the highest atmospheric layers. And so we return to where we began, looking up at that familiar silver disk, but now with eyes that see so much more. The moon that watches over your sleep tonight is not the simple, unchanging companion we once thought we knew. It's a world of impossible shadows and vanished magnetism, of buried metallic hearts and ancient water ice, of thermal extremes that crack stone and seismic pulses that ring through airless space for hours on end. Every night, as that ancient light touches your face, you're receiving photons that have bounced off a surface scarred by billions of years of cosmic violence, yet somehow still maintaining its gentle vigil over our restless planet. The moon pulls at your very atoms with invisible threads of gravity, connects you to underground tides flowing in caverns you'll never see, and synchronizes your world with rhythms older than complex life itself. Perhaps most remarkably, we've discovered that strangeness and familiarity can coexist in the same celestial body. The moon that inspired countless poems and guided ancient navigators is also an alien world where shadows are absolute voids and water hides in the coldest places in the solar system. It's a reminder that even the most intimate objects in our lives can hold mysteries that stretch across deep time and vast distances. As you drift towards sleep, let the moon's quiet complexity settle in your thoughts. We are not alone in this universe, not because we've found other life, but because we share our cosmic neighborhood with worlds so strange and wonderful that they expand our very definition of what's possible. The moon has been humanity's first glimpse into the profound weirdness that lies hidden in plain sight, waiting for curious minds to notice, to wonder, and to explore. Sweet dreams, fellow travelers. The moon will continue its ancient dance overhead, keeping secrets we're only beginning to discover. And when you're ready to explore another cosmic mystery that challenges everything we thought we understood about our place in the universe, join me for The Universe is Trying to Tell Us Something, sleep documentary, where we'll discover that the very laws of physics might be hiding messages in the structure of reality itself.